taking the square root of 3364 and we're subtracting 3220, right? Yes? And we get the square root of 144, so we know the coordinates of the sun are... How do you know it's 12, 0 and not negative 12, 0? It's on the positive side, so 12, 0. Perihelion refers to the point at which the planet is closest to the sun in the summer. At this time, how far is Mercury from the sun? And how did you get 46? 58 minus 12, okay? 58 minus 12. Why did you do 58 minus 12? Okay, that's what summer is. And this is 12, right? Okay, see, this is 12. So it's actually what? 46 million miles. Okay? Ahelion? Okay, refers to the point at which a planet is farthest from the sun in winter. At this time, how far is Mercury from the sun? Because you did 58 plus 12. And that should equal 70. And in this case, 70 million miles. An equinox occurs when periods of daylight and darkness are equal lengths during the day. A planet experiences an equinox twice a year. Excuse me. In the fall and in the spring. In terms of the ellipse, this occurs at the point directly above and below the focus, or in this case, the sun. What are the coordinates for these special points? You got to show your work. Any ideas? So we're trying to find, like for spring, we're trying to find, or fall, let's do fall first. We're trying to find that point right there, right? What's the x value of that point, guys? 12. So what if we put 12 into our equation? Oh, okay. So we do 12 squared over 3364 plus y squared over 3220 equals 1. How do I solve that? Yeah, what is this? What is this decimal? .04 plus y squared over 3220 equals 1. So how are we going to solve for y? Jesse, tell me again what this is. Let's go to the thousandths on this one. 43? Okay. So we need to subtract .043 from both sides. So y squared over 3220 equals what you got? What? 05957? You guys just making up numbers or what? And now what? Okay, so multiply each side by 3220. Y squared equals 3081.54. So do I know an answer yet? I have to solve for y, right? Say it one more time, please. So then tell me what fall is. Tell me what the equation or the location of fall. And tell me spring. just regular 12, but negative 55.51. Any questions about that? Okay, make sure you do the back before you come tomorrow. Okay? I mean Monday. So pretty obvious, but which conic section were we talking about here? Ellipse, right? Okay. So what about this one? Cooling tower. Which one do you think? Hyperbola, right? Okay. And you can tell that because this tiny, tiny equation, they're both squared with opposite signs. Good call. Okay. All right. Power plants use water in cooling towers to transfer heat generated in energy production. The Didcot Power Station in Oxford, England has 6 such cooling towers, each approximately 100 meters tall. While the towers appear circular from above, they're actually hyperbolic in shape when viewed from the side. An equation to model the cross-section of one of these towers is given to the right. A key. Isn't that girl's name in James Bond, Jared? Aki? In Moonraker. Her name's Aki. That's the scientist. The Oriental girl that he has to pretend to marry. That's Aki. Okay. So with this model, tell me what you know. X and Y values are measured in meters. X-axis represents the ground. And the Y-axis, axis of symmetry, okay? So on the bottom, what does it mean not on the bottom? Like the bottom circle? So wait, are we actually doing like circles and hyperbolas? Dun dun dun. Find the coordinates for point B. How are you going to find the coordinates for point B? If we have an equation, excuse me, if we have an equation, say it again. When x equals 0 or y equals 0. Yeah, see how it's on the x-axis? So we got to solve for x, but we know that y equals 0. Okay? So if y equals 0, put a 0 in for y and solve here. I'm not going to do this for you. I'm going to let you do it in just a second. I'm just kind of trying to guide you along. The x-coordinate for B is the radius of the tower's circular base. How many meters would it take to walk around the base of the tower? What are they asking for? Circumference. So on this one, we're letting y equal 0. Okay? Excuse me. Look at the top, on the top. In the diagram, point T represents a point on the top edge of the tower. Find the coordinates for point T. What do we know? We know its y value is 100. So y is going to equal 100, and you're going to solve for x. The x-coordinate of point T is the radius of the circular top of the tower. If a lid was to be constructed to cover the top of the tower, how many square meters would it cover? Area. We're looking for area. Okay, so as soon as we find that point T, we'll know the radius, won't we? And we can find the area. Okay, fill it up. Imagine filling the tower with water. A formula to find the volume of water in this tower is given right there. Okay, find the volume of the tower if the tower is to be filled to a depth of 50 meters. So you're just going to substitute 50 in for H. Okay. Find the volume if it's 100 meters, so plug in 100 for H. Why is the answer to number 6 not twice as much as the answer to 5? This is a thinking deal for you guys, okay? I didn't write anything out to the side right here because it kind of is like right here, okay? Any questions on this? All right, you have the rest of the period to finish it. Whatever you don't finish in class is homework. Kingston out.